I think I stop. Here at here on Thursday, right? So we had to solve a problem. We have before we do any calculations. Remember, we need to draw the free-body diagram and draw the diagram separately. Okay, separately. And so we have four forces. Remember, we have four forces, and we draw these four forces. And if we know the magnitude of the force, then we write the magnitude of the force. Okay. If we don't know that, it is fine. It is okay. And if we know the angle, that we write down the angle. Now here that this is equilibrium equation, and before we go on, we first determine alpha and beta. And because in the problem we know these distances. Distance 距离啊。So we know these distances, so we know alpha, we can determine alpha and beta, right? We can determine alpha and beta. Now, and just to go, I know you know how to do them, and so alpha is arctangent, and 7/4 is 60.26 degrees, and beta is arctangent of 1.5/4. Remember, in English we will say 1.5/4. 1/4. In English is we say this first, and then we go to the denominator. 1.5/4 is how much? 20.56 degrees. Now, so and the rest of it is straightforward. Straightforward, yeah. And you fill in the table, and so we have TAB equals to 200, and then TAC is unknown, TAE is 300 Newton, and FD is unknown, right? And for the angles that we have 150.26 degrees. Remember this for this one, that for TAB the angle is alpha is 60.26 degrees, but the angle of TAB is should we come from the right, or from x-axis or from y-axis? We count from the angle from x-axis, okay? We come from here. So this is 90 plus 60 is 150, okay? We count from the right-hand side, we count from here. And then we get 150.26. And TAC is, so beta is TAC, and remember that we count it as positive if it is counterclockwise, but here beta is 20.56 degrees this way, okay? So the final angle is 69.44 degrees, okay? And you know the other two, and one is this one is 270, and this one is 60. Now, and you can do the rest. And remember, so you can go home and read the textbook, or you can simply do all the calculations and get this. And remember, what is the resultant of all forces after we add? If we add four forces together, what's the magnitude of the sum of the four forces? What's the sum? 0, right? Because we have summation F equal to 0 above here. So remember that the magnitude is equal to 0. And of course, the x component is equal to 0, and the y component is also equal to 0. Okay? And now we have, of course, so you can, from these two columns, you can write these two equations. I think you can do this. From these two columns, you can write down these two equations. But in examination or quizzes, please write down. Please write down this. So please write something in the front. So and I should write it down. And this one is. Let me write it down here, and I can talk about them a bit more clearly. So take your time to write this down. Okay. I want to check one. I want to see one thing. So, I think, so you can see that this one comes from this one, right? If we take into account of, if we consider this and in this direction, and the second equation comes from the y direction. So, this one comes from x direction. The first equation comes from equilibrium in x direction. So please write down summation fx equal to 0. Sorry, I should. And I think you should write it down like this. Okay. You please write it down. Please write why you think this one is correct, because you think this one is correct because you get this from summation fx equal to 0. So what should we write in the second before the second equation? For the first equation, we have summation fx equal to 0. So what should we write for the second equation? Summation f y equal to 0. Very good. Please write this down, okay? The thing is, if you do every in exam or in quizzes, if you do every calculation correctly, then it is fine. But if you make mistakes here or there, I don't know why you get those wrong. But at least if you write it down, okay, this is summation fx equal to 0. I will look at here and see where do you have mistakes. Okay. So please write this down and let me, if anything here is wrong, then I can, in English we will say, trace the problem back to where does the problem come from. Okay. So for these two equations, then you can do it by hand or you can do it by calculator. You can do it by calculator if you know how to do it. I think I will take a look at one of your calculators at the break and see how I should go with it. Okay, so now that we have the answer will be TAC equal to is equal to 214.45 Newton, and FD is equal to 98.35 Newton to the right. And these are the answers. So I know you know the mathematics, but in this problem, please there are two key points. The first one is you raise it up first. There are two. So in this, take your time to write it down. But for those of you who have finished writing, that two key points. The first point is after you draw the table. After you draw the table, that before you go on with writing down the equations, remember to write it down. Where does this equation come from? Here is summation mx equal to 0, summation m1 equal to 0. Okay, this is to protect yourself 保护你自己啊。写错东西最少我可以更好。OK 吗？ So this is the first point. The second point is before we do any calculation, remember to draw the figure diagram. Okay, I've told you that it counts like 20% or 25%, 30% of the mark, 25% or 30%. Okay. Okay. So take your time to write it down, and if you have finished writing it down, then we go to you can go to the next page. So on the next page, then we go on with three dimension. We go beyond. We go beyond 2D and we go to 3D problem. We go to 3D problems now, and we have so we are talking about the 3D space. Now the problem is it is a bit more difficult than 2D because this. Let me draw it here. So suppose we have a force F here. This is X and this is Y. And let me in 3D let me plot it like this. This is theta X and this is theta Y. And theta X is the angle between F and positive X axis. Okay, and I would say from now on for positive I will simply write this one. and theta y is of course the same logic, and angle between f and positive y-axis. Take some time to copy it down, and I will show you something. After you write it down, that think about, do we know anything if we know theta x in 2D problem? If we know theta x, do we know theta y? In 2D problem. So if we know theta x, what do we know about theta y? So in 2D problem, that so is there any relationship between theta x and theta y? Relationships, once you know theta x and theta y. What do we know between them? Theta x plus theta y is equal to, if we know theta x, and of course we know theta y, right? If this is 50 degrees, then this is 40, right? So if this is 10, and this is 80, okay? So theta x plus theta y is always 90 degrees. So, and for the rest, then I cannot draw it, so I have this one, and you can play with it afterwards. So for those one, this is the thing I post on iLearning this morning, and so if we consider only x and y axis, if we only consider x and y axis, then if we know theta x, and theta x plus theta y is always 90 degrees, right? But now if we have, this is the new one this year, so it's simple. So if x is here, y is here, z direction is going this way, right? And right hand rule that x, y, and then z by right hand rule. So if the force has a z axis component, say the angle goes like this, and you can see that of course we have a theta y here and theta x here, but we have a gap here, we have some space here. Okay, so it means in 3D, theta x plus theta y is larger than 90 degrees. Okay. So now you can play around with this. Then go on. Okay, you can take a look of the little piece of paper there. Now, so of course this is larger than 90 degrees, but what does it equal to? So what does it equal to? So we don't know yet. We don't know. Let me in 3D program. So and z direction is going out of the paper. So we also have let's see. It is an angle between f and positive z axis. So we have three angles, and I will talk more about it later today. Let me take a break here.